My name is Roberto Zubieta, and I am today going to talk about this blockchain vaccination registry, which is a project I made last year. This is about practical applications of blockchain beyond cryptocurrency. So other crazy stuff that you can do besides just changing coins between people. So first off, about the author, this is my bragging rights. My name is Roberto Zubieta. I'm from Panama. I'm a certified blockchain developer by consensus last year, 2009. And also have 2 years of experience of work in blockchain applications, production blockchain applications. Okay, this is the problem that we are trying to solve right now. Vaccination registries are around not only the developing world, but the entire planet are very difficult to maintain. They're difficult to maintain because each country, each jurisdiction has to have its own application, has to have its own database, has to have its own software, and normally it's not interoperable between different jurisdictions. It's difficult to register because since each jurisdiction is trying to create its own application, they never think of the user experience. They don't think of all the small steps people must implement in order to create a good app. They're also difficult to append. At some point you must add extra data alongside it, but data must also be able to be able to be audited. That data is real. They're difficult to share amongst jurisdictions. Since each jurisdiction has its own application at this point, there's no interoperability. There's no interoperability thought of it, and it's also difficult to report on because each report must be programmed and must be built from the get-go. So, what's the solution for this? Blockchain. But why? First off, it's decentralized. The application itself does not reside in any single. Hypothetical blockchain application will not reside in a single physical space. It will exist at the same time in hundreds of nodes around the world. There will be a node here in Panama, a node in Spain, a node several nodes in the United States, probably nodes in the same country that it's been registered, and they're all synchronized at the same time. They're also transnational, so not a single jurisdiction can affect it. Not a single jurisdiction can try to block it at some point. It's also non-custodial, since no one is in control of the application. Not a single person can be attacked or purchased or corrupted in order for the application to work in a way that's not intended. You cannot what was the word? You cannot bargain against math. It's just math. It either works or it doesn't. It's tamper resistant. If somebody makes a registry, you know who made it. You know when it made it. You know why it made it. If that person, by default, if it made a registry, it had to have the permission. So you know who did it, when it did it, and how it did it. Resilient. In case something happens in the country, like say the country at this point is on some sort of a civilian breakdown, like what's happening in Syria, like what's happening in Sudan or other countries. The registry still exists because it does not exist only inside the country that's having the breakdown. So you have some sort of disaster recovery for the data itself. Also, it's open standard, so you can create your own applications on top of it. You can create your own reports. You can create your own. You can create all kinds of data data pipelines alongside on top of it. Also, a very big thing also is the free reads and cheap writes. Writes do cost money. Each write does cost a crypto in order to be executed, but reads are free. Anybody can read it as if it were a website. You can just go to any node and read the data, and you can then process it and make reports of it. Anyone can do it. It's because, as I said, open standards. Anyone can really make reports of it. So, in order for this to work, I made a small proof of concept behind this for an hypothetical application that will register vaccinations. That will register vaccinations in the blockchain. It's a simple thing. It's right now working on the Ethereum blockchain. It's using the ERC1155 token standard, a cryptocurrency token. Each vaccine is an NFT token that is called D in Ethereum parlance. Each public address is a person. It has the front end, how you see it, how you interact with it is React, and using Truffle Suite behind as backend. Okay, let's go over that piece by piece. I know it's a lot of different tools. First off, backend at the base, I'm using the Ethereum blockchain because it's the second most successful blockchain network behind Bitcoin itself. In this case, it will work similar to an electric grid, as in you pay for it and you get lights and you get your coffee machine working. But the big thing about why I'm using Ethereum and not Bitcoin is because Ethereum also works as a decentralized global computer. You can run some small programs inside the blockchain itself, and those programs are called contracts, and those executions will validate across all the nodes. And once those nodes are, and once those calculations are validated, they are registered inside the blockchain. They will essentially work. They will work similar to AWS Lambda plus MongoDB Atlas for the database. It's similar to that. The way that works is using smart contracts, which can execute Turing-complete programs. Those are small. That's a small software that you compile and you upload to the Ethereum network, and it will execute your commands according to what's in the program. It looks similar to a Java class. Once you see it, you'll understand it. For example, this is at the right. You see one sample contract, a sample contract interface. This is the ERC20. This is the ERC20 standard contract. If you want to make a token of any kind, you just have to make a small class in Solidity, the language that is used to make contracts, that implements this interface. It's essentially a Java class. You can make any kind of token with only this interface at the right. So a token contract. So in other words, it's a simple hash map. It will work as a hash map in Java. The keys are the user addresses, and the values is the balance of each address. That's stored in memory, and all you have to do is, if you get balance for each user, is just looking for a value for an individual key. Okay, it's a hash map. It's a hash map, a memory hash map. Then once you have that's essentially how a token works. There are two kinds of tokens actually. There are the ERC20 tokens, which are the ones on the right, which are similar to US dollars, in that you can split a single token to smaller pieces, which will be in dollars, will be cents, but the standard is to having 18 zeros, so as you can make very small fractions out of a single token. The other kind of token that we are seeing a lot is the non-fungible tokens. The standard for them is ERC721, similar to the one at the right, which essentially is the same thing, just that each token is individual and cannot be split. There will be like a deed or like a property deeds here in the Panama, that it will be the registro de propiedad. Who owns this property? Who owns this land? The land cannot be split easily, but you can change you can see who owns this land. Simple famous tokens that are using these standards. For fungible, you have the first one, which is MakerDAO and DAI, which is an incredible project as a self-sufficient central bank that works entirely in blockchain, and all decisions are made in the blockchain. So nobody is involved in the value of the token itself. That way, you can guarantee that one DAI is always almost always equivalent to $1. There's a few cents of difference, 1 cent of difference normally, but one DAI is essentially equivalent to $1, and no human is involved in the price decision itself. It's an incredible project. And there's also the Brave browser and the BAT, which is a token that is used as a way to. This one is designed by Bill Eichner, which is the creator of JavaScript, and this is a project that's trying to upend the entire ad tech business, which the core of it is using the Brave browser. By the way, that's what I'm using right here. For famous non-fungible tokens, the popular ones are actually games. That are the ones that are most common right now. The big one is the CryptoKitties. Those are essentially collectible cards. Each CryptoKitty is a token, but it's completely individual. And since it's a kitty, you cannot split it. So you know who owns each drawing. You know who owns each cat. And Gods Unchained is also another famous one, which is something like Magic the Gathering, but web. It's a game similar to Hearthstone, but the cards but the ownership of the cards is registered in the blockchain rather than registered in their servers. So if they go down for some reason, you can still use them. Okay, now that we understand tokens, I can explain exactly what the ERC 1155. For this project, I use instead of using those two standards I talked before, I'm using the ERC 1155, which is a newer standard that instead of a single token, it defines a list of tokens. So it's a hash map of a hash map, essentially. You can create each different token can be fungible or not fungible. So you can have in the same memory space, you can have coin tokens, and you can have deed tokens. And an administrator can create new token types, which is the big part and the one that I'm going to use a lot right now. So it's time for the live demonstration. Okay, first off, I'm using this software here, which is called Ganache. Ganache is essentially a blockchain it's a software that emulates a blockchain inside a single computer. It gives me, if you can see, several addresses and some test keys, but that's only inside this program. So I cannot expand it outside. Okay, in this blockchain, I'm going to deploy the contract so that I can use it. The contract is right here. This code is open source, it's in my GitHub. I will give the link later. But I'm using exactly this one, ERC1155. You can see it's a simple. You can understand it. It's simple. It's a mix of Java and C. This is the ERC1155 implementation, the demonstration by Engine Point. Sorry, this one is the one I'm using. The ERC1155 mintable. Using Truffle, the Truffle will compile that contract into bytecode, similar to how Java works with the Java virtual machine, and it will upload it to the and it will upload it to this using this address and this balance. There. As you can see, this address now has a little less balance because it deployed this contract. And here is the cost of that, and here is the cost of that deployment. It costed me 5 cents of ether. That's around 15 cents. 15 USD.
That was original transaction?
Huh?
Real money transaction or simulation?
No, this is here. This is here. This is a small test blockchain, so I can do whatever I want here, and it's free because this ether is only it's play ether. It's monopoly money at this point. But right now I have this contract. Ganache allows me to see the contracts that I have deployed. And here is the contract I just showed you. Here is the address of that contract. How many transactions have I done already in it? So, well, this is not very useful for a big application because very few people can access the data here. So what I'm going to do is I'm going to access this data from this blockchain via a React application. CD client. Let's go to the client. Oh, I'm already. Here it is. Don't look too hard in the application. It's just a proof of concept. It's ugly. The code is uglier, but the point is that it gets the job across. What's happening here is that it's actually reading from Ganache, from the blockchain itself. So the data layer is the blockchain. It's using it as a backend. In this application, I have two kinds of users: the issuer and the auditor. The issuer creates vaccination tokens and assigns that token to a patient. So I'm going to pretend at this point I'm an issuer. I'm somebody in the middle of this is the application I'm using, and I'm a doctor in the middle of the jungle, and I just want to register that somebody received a new vaccine. Okay, first off, the vaccine must exist, and then the vaccine must be created by the administrator, not by the person that's sitting in the middle of the jungle. So first, I'll be the administrator, and then I'm going to create a new vaccine. Let's say COVID vaccine, but the version, let's say invented by Bayer, which is a big pharmaceutical. COVID buyer. Back. There's a new vaccine. There is a new token created, which is the COVID vaccine created by buyer. Now, let's go back to the jungle, and I need to vaccinate somebody. Okay, somebody. It is a good thing that I have prepared a small, how's in English, guinea pig for this experiment. Juliet, can you come across?
Sir.
Okay, here's my guinea pig. In this case, she will be the patient. Okay, I need to prove your identity, please. Thank you. Okay, can you give me? Yeah. Right now, she's using one of these identification cards with a small pin, with a small chip. This is the Estonian one, the most famous one, and she will, in theory, just have to. I need to open this.
Yeah.
Open it, please.
Yes. We pass it like this.
Thank you. Okay, she passed me the card, and I'll just have to register it. Okay, I do not know how to use it.
So basically like this. You just log in.
There. Now, just put it here.
Pero no sé si lo te va a servir si no tienes la
There. Now she just gave me her identity, and she proved her identity with the card. Only that card has a private key inside. So once she proves her identity, I'll have a public key, which in this case will be this one. This is the public key this is the testing public key for this application. And I just gave her a vaccine, so I only have to register it to the blockchain. So this to her address, which is this one, I am giving her the vaccine ID 1, which is the one that I just created. There, it's registered. Success. It's registered. Thank you. Thank you. Have a nice day.
Thank you.
Now the fact that she was vaccinated is registered in the Ganache blockchain. So, but in a production application, it will be registered to the Ethereum blockchain, and anybody in the world will see that she already had that the card that creates this public address has had this vaccine. Anybody in the world. And if something happens to that country, or something happens to that government, the registry is still there and cannot be tampered with. Let's say if the government is trying to hide the fact that it's anti-vaxxer and does not believe in vaccines, they will start seeing that less people are getting vaccinated. The rest of the planet will see that less people are getting vaccinated. So, if you see here, back in Ganache, back in the contracts, back in this contract in particular, you'll see that it already suffered several transactions. These are the transactions that happened between it. Here it created a new token. This is the COVID buyer token, with ID 1. This is the creation of the token. And here it says that a transfer single, that a single token was transferred to the address. This is the public data. This is the data that anybody can see anywhere in the world. That each transfer is public. Each creation is public. Anybody can see it, and can of course do big data with it. So let's try that. Now I am, let's say, the WHO, the World Health Organization, and I'm in a comfy office in, let's say, Tokyo. something. And I want to see which vaccines are registered. First off, it immediately registers there all the vaccines that are in the blockchain. That's a read. I can try refreshing it so that you can see that it's not being stored in memory. It's being stored in the backend, in the blockchain. Here, these are all the tokens that have been created right now. All the kinds of different vaccines. And let's say that Juliet again comes, and she's now a refugee, and she has not necessarily a refugee. She has migrated to Japan, and I'm in Tokyo, and I need to see her health, her medical records. So if she just passes her card again to me and gives me her public address, I can look at at that address all the tokens that she has received, which will be this one. This is the public address, and looking for all the vaccinations that address has received. It under what circumstance, and you know what happened.
This is basically a public ledger.
Essentially, it is a public ledger, but the big thing is that it's also non-custodial, so that even if let's say you can't even force the company that holds the data. In this case, will be Amazon or MongoDB. They could theoretically change the data because it's in their servers. They could theoretically do it. Here you cannot.
Sorry, I want to continue with that.
Okay. Well, this is of course not a perfect solution. There are several remaining challenges that I wish to discuss. The first challenge is identifying people. In other words, how to prevent fake IDs. In this demo, we used one Estonian ID card. Those only exist in Estonia. So how will we do with people in the middle of the jungle? How will we identify them? That's a hard problem, not only in crypto space, but also in digital space. How will Google know how can I access my Gmail when this is assigned to me? Do I need a password for this? Do I need a username for this? Identifying people in the internet is difficult, and it's double difficult in crypto space. There also another big problem I detected in this proof of concept is privacy. If you know somebody's public address, you can see their entire medical records, their entire vaccination records, which is a very big privacy problem. Yes. So maybe using zero knowledge proofs, which essentially you give a question to the blockchain, and the blockchain answers you, but you do not know the underlying circumstances. Say, if I can ask, this address was vaccinated, and the blockchain returns yes or no, but it does not return the address or the tokens of the vaccination. Zero knowledge proof is a bit of arcane dark magic for me still. I'm still trying to wrap my head around it, but that will give some degree of privacy, and that's a solution. That's a second part probably. There's also the thing of bureaucratic inertia, in that paper records work as at this point. Paper records work, and there has been as long as a state is working, as the country is working, as long as everything's fine, paper works fine. But it's in the moment that there's a crisis that more robust solutions are needed, and at that point you are having bigger problems than vaccinating people. You're talking about migration issues and stuff like that. So it's difficult to implement a system like this in the entire planet when the current system works fine. Thanks for your attention.